Every data center has one constant problem: heat. Servers, processors, storage devices, and network equipment all generate large amounts of heat every second they operate. If that heat is not removed fast enough, equipment temperatures rise, systems can throttle, alarms can activate, and critical operations can be affected. That is why cooling systems are one of the most important parts of a data center. In this video, we are going to explain the difference between air-cooled and water-cooled data centers, how each system works, and why one may be selected over the other. The biggest difference comes down to one thing: how the heat is rejected outdoors. In an air-cooled system, heat is rejected directly to the outdoor air using equipment like air-cooled chillers, condensers, or dry coolers. In a water-cooled system, heat is transferred through a water loop and usually rejected through cooling towers using evaporation. Both systems can cool data centers effectively, but they each have advantages and disadvantages. Let's start with air-cooled systems. In an air-cooled data center, the cooling system removes heat from the server room and rejects that heat directly to the outdoor air. A common example is an air-cooled chiller. The chiller produces chilled water for the indoor cooling units, but instead of using a cooling tower, condenser fans blow outdoor air across coils to reject the heat. Some smaller data centers may also use DX systems, where refrigerant absorbs heat from the room and transfers it directly to an outdoor condenser. Air-cooled systems are popular because they are simpler. They do not require cooling towers. They do not require condenser water pumps. They use little or no water for heat rejection, and they avoid many of the water treatment requirements associated with cooling towers. This makes air-cooled systems attractive in areas where water is expensive, limited, or heavily regulated. They are also common in smaller data centers, edge facilities, and retrofit projects where simplicity and speed of installation are important. But air-cooled systems also have disadvantages. They are generally less energy efficient than water-cooled systems, especially in hot climates. As outdoor temperatures rise, the equipment has to work harder to reject heat into the already hot air. That increases energy consumption and can reduce cooling efficiency. Now let's look at water-cooled systems. In a water-cooled data center, heat is transferred through a water-based system and usually rejected through cooling towers. Here is the basic sequence. Indoor cooling units remove heat from the server room air. Chilled water carries that heat back to the chiller. The chiller transfers the heat to a condenser water loop. Then the condenser water travels to a cooling tower, where evaporation removes the heat from the system. Water-cooled systems are often more energy efficient because water transfers heat more effectively than air. This becomes especially important in large data centers with massive cooling loads. Water-cooled systems also work well for high-density environments because water can move large amounts of heat more efficiently than air alone. That is one reason many large hyperscale data centers use water-cooled central plants. Another major advantage is economizer operation. During cooler weather, cooling towers or fluid coolers may help reduce or partially replace mechanical refrigeration, improving overall efficiency. But water-cooled systems also have disadvantages. They are more complex. They require cooling towers, pumps, piping, and water treatment systems. They consume water through evaporation, and they require more maintenance. Water quality becomes critical because poor water treatment can cause scaling, corrosion, fouling, and reliability problems. This is why the decision between air-cooled and water-cooled systems is not simple. Air-cooled systems reduce water usage but often use more electricity. Water-cooled systems can improve energy efficiency but consume more water. The best choice depends on climate, utility costs, water availability, rack density, sustainability goals, and long-term operating strategy. For example, a data center in a drought-prone region may favor air-cooled systems to reduce water consumption, but a massive hyperscale facility with very high cooling loads may choose water-cooled systems because the long-term energy savings can be significant. This is also where two important metrics come into play: PUE and WE. PUE stands for Power Usage Effectiveness and measures energy efficiency. WE stands for Water Usage Effectiveness and measures water consumption. A water-cooled system may have better energy performance but use more water. An air-cooled system may conserve water but use more electrical energy. Modern data center owners have to balance both. Now let's clear up one common misunderstanding. Air-cooled does not necessarily mean the servers are cooled only with air. And water-cooled does not necessarily mean water is flowing directly to the servers. Many air-cooled data centers still use chilled water inside the building. The difference is that the heat is ultimately rejected to outdoor air. And many water-cooled data centers still cool the server room using air handling units. The water is mainly used in the central plant to transport and reject heat more efficiently. As rack densities continue to increase, especially with AI and GPU workloads, the industry is also moving toward liquid cooling technologies like direct-to-chip cooling and immersion cooling. We will cover those systems in future videos. But the key concept to understand is this. Air-cooled systems reject heat directly to outdoor air. Water-cooled systems reject heat through a water loop, usually using cooling towers and evaporation. Air-cooled systems are simpler and conserve water. Water-cooled systems are more efficient at large scale and better suited for very large cooling loads. Neither system is automatically better. The best solution depends on the project, the climate, the utility costs, the available water supply, and the long-term goals of the facility. Because in the end, every data center cooling system is trying to accomplish the same thing: move heat away from the servers as efficiently, reliably, and safely as possible. If you found this video helpful, be sure to check out our HVAC and plumbing estimating spreadsheets to streamline your construction bidding process. Check out our HVAC, electrical, and plumbing construction forms to help you run your business, and explore our online courses for in-depth training.